Welcome to the DIY Honda Garage channel. In this presentation, we will address the diagnostic trouble code DTC P16E6, which indicates a malfunction in the transmission range switch start switch circuit, specifically for the 2016 to 2021 Honda Civic. This code often suggests an issue that can prevent the engine from starting, making it crucial to appropriately identify and rectify the problem. The transmission range switch is a critical component that helps determine the position of the transmission, providing crucial data to the powertrain control module, PCM, regarding the operating state of the vehicle's transmission. The PCM uses this information to manage engine performance and control startup operations, ensuring that the vehicle can only start in a safe gear position, such as park or neutral. A malfunction here can lead not only to starting issues, but potentially compromise overall vehicle safety. This guide will outline how to troubleshoot and resolve the P16E6 error code systematically. The DTC P16E6 signifies a malfunction in the transmission range switch, specifically related to the start switch circuit. This component is located directly on or near the transmission of the Honda Civic, serving as a crucial interface between the transmission and the powertrain control module, PCM. Its primary role is to inform the PCM about the specific gear position of the transmission, enabling it to assess whether the vehicle is in a safe state for starting. When functioning correctly, the transmission range switch ensures the vehicle can only start when shifted into park, P, or neutral, N. If this switch fails, it can signal incorrect information, resulting in the inability to start the vehicle, potentially stranding the driver and causing frustration. It is essential to accurately diagnose and repair any faults within this system to ensure reliable vehicle operation. Several factors could lead to DTC P16E6, which must be considered during troubleshooting. First, a faulty transmission range switch is a primary suspect. If this component isn't functioning correctly, it cannot provide accurate gear position data to the PCM. Secondly, there could be a short circuit present in the ATPST, automatic transmission position switch wire, or the ATPST, automatic transmission start line. This short could lead to incorrect signals being sent, mimicking the symptoms of a malfunctioning switch. Additionally, poor connections or loose terminals, either at the transmission range switch or the PCM, can interrupt the communication necessary for correct operation, leading to intermittent issues. Addressing these potential causes in a systematic manner is vital to resolving the DTC effectively. The symptoms associated with DTC P16E6 can significantly impact the vehicle's usability and the driver's peace of mind. One of the most evident symptoms will be that the engine simply won't start. This is often the first indication that something is seriously wrong. Additionally, drivers may experience intermittent starting issues. The vehicle might start sometimes, while at other times it will not, leading to frustration and unreliable vehicle behavior. Furthermore, a faulty transmission range switch can cause incorrect indications regarding the gear position, which could mislead the driver into believing the car is in a safe position for starting, when it is not, posing a potential safety risk. Recognizing these symptoms early on can assist in swiftly diagnosing the problem and preventing further complications. To begin troubleshooting the P16E6 error code, the first step is to ensure that the vehicle is in the on mode. Once the vehicle is turned on, it's essential to use the Honda Diagnostics System, HDS, to clear any existing DTCs from the system. This step refreshes the vehicle's diagnostic data, allowing technicians to start with a clear slate. After clearing the DTC, shift the transmission to a position other than park, P, or neutral, N, and wait for approximately 5 seconds. This waiting period allows the system to reassess and potentially identify if the error code reoccurs, indicating a persistent issue. Following this process aids in determining if the error is confirmed or if it was merely an intermittent fault. In the second step of troubleshooting, turn the vehicle to the off or lock mode to ensure safety while working on the electrical components. Once the vehicle is off, disconnect the transmission range switch 10P connector. This disconnection is crucial for isolating the switch to determine if it is the source of the problem or if other components, such as the powertrain control module PCM, are involved. With the connector removed, check for continuity between test points 1 and 2. Specifically, test point 1 will be at transmission range switch connector number 7, while test point 2 should be connected to the body ground. This continuity check will help identify if the circuit is intact, or if there are breaks that may indicate a wiring issue, leading towards the next steps in troubleshooting. The third troubleshooting step requires shifting the transmission to a position other than park, P, or neutral, N. This action helps verify that the transmission range switch is detecting the appropriate gear position. Following this, again check for continuity, with test point 1 at transmission range switch connector number 7 and test point 2 at connector number 1 of the same switch. By doing this, we are evaluating whether the switch is operational by checking if a complete circuit exists when the switch is in the correct position. If continuity is present at this stage, then the switch must be replaced, as it indicates a malfunction that affects its ability to correctly relay information to the PCM. Alternatively, if continuity is absent, it implies that there may be issues with the connections or the need to further test the transmission range switch or the PCM. In the final troubleshooting step, start by jumping the SCS, service check signal, line using the HDS. This act of jumping allows for the collection of diagnostic information while ensuring other systems are not interfering. After performing this, disconnect the connector from the transmission range switch 10P and the PCM connector E 80P to ensure that the circuits are entirely isolated for testing. Next, check for continuity between test point 1, which is PCM connector E number 67, and test point 2, the body ground. If continuity exists at this point, it suggests that there is a short circuit in the ATPST wire running between the PCM and the transmission range switch, requiring repair. Conversely, if no continuity is found, the wire is intact, indicating that further investigation into the DTC and its symptoms is necessary, potentially including PCM replacement if a malfunction is confirmed. After completing the necessary repairs and component replacements, it is essential to perform a thorough final repair verification to ensure the issue is fully resolved. Begin by verifying that any replacement parts, such as the transmission range switch or PCM, have been correctly installed and are functioning as intended. Once verified, recheck the system for any diagnostic trouble codes, DTCs, using the HDS. This rechecking is critical to confirm that the P16E6 code or any other related codes are no longer present. Finally, attempt to start the engine to confirm that it operates correctly, ensuring that it starts smoothly and without any issues. This final step confirms the repair's success and that the vehicle is safe and ready for normal operation. To prevent future issues related to DTC P16E6, implementing a preventive maintenance plan is crucial. Regular inspections of the transmission range switch and its connections can help catch any potential problems early. Ensuring that all electrical connectors are secure and free from corrosion will enhance the reliability of the circuit. This is especially important given the presence of moisture and dirt in typical driving environments. In addition, checking the condition of the wiring, particularly the ATP-ST and ATP-ST lines, can prevent shorts that could result in another malfunction. Taking these proactive measures not only prolongs the lifespan of the components, but enhances the overall safety and functionality of the vehicle. In conclusion, understanding and effectively troubleshooting DTC P16E6, which points to a malfunction in the transmission range switch start-switch circuit, is critical for maintaining the Honda Civic from 2016 to 2021. By following a systematic troubleshooting process, mechanics can identify the source of the problem through a series of well-defined steps, ensuring that each component is tested and properly evaluated. Addressing common issues such as faulty switches, shorts in wiring, and loose connections is essential for resolving the error code. Implementing appropriate repairs, including parts replacement when necessary, is imperative to restore functionality. Finally, routine maintenance checks will help to prevent recurring issues, maintaining vehicle reliability, and ensuring that the vehicle remains safe and operable for the driver. Please like and subscribe to the channel. See you next time.